Okay, let's jump into our review on solving systems of equations and inequalities. We're going to start by graphing the following and looking for the ordered pair solution. So I want you to recall that we start by graphing the 2 on the y-axis because that is my y-intercept. It's where the line crosses the y-axis. And then the number in front of the x term is my slope. So here it's understood to be 1 over 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. I can go in the opposite direction, down 1 and over 1, and put those points, and then I can put my line to connect those points. Okay, now we want to graph the other equation. I'm going to do it in this blue color. So we're going to graph y equals 2x plus 3. Again, we look at the constant. The constant tells us where our line crosses the y-axis. At this point, I'm hoping that everybody has this memorized. The slope, the number in front of the x term, tells me to go up 2 and over 1, or I could go down 2 and over 1, and we quickly see that point of intersection is right here at negative 1, 1. So my ordered pair solution is negative 1, 1. And because we have one solution, we say our system is consistent and it is independent. One is independent. So consistent and independent. Okay, so let's look at the next one. Oh, also, let me point out real quick, you can plug that back in and check. Negative 1 is my x value, plus 2 should give me a y value of 1. If we do the math, negative 1 plus 2 is 1, 1 is equal to 1. Same thing over here, 1 should be equal to 2 times negative 1 plus 3. Compute it, 2 times negative 1 is negative 2, negative 2 plus 3 is 1, so it checks. All right, so now for the next one, we've got to determine if it's consistent or inconsistent. Is there a solution or is there not a solution? So first I need to get my y by itself so that I can begin to graph it. So I have y equals negative 1x plus 1, and y equals negative x plus 6. So I immediately know that there is going to be no solution. If we want to graph it, we can, but I know that there's going to be no solution. How do I know this? Well, let's look at my slope. The slope of both lines is negative 1. So they have the exact same slope, but then they have different y-intercepts. So that tells me that one's starting at positive 6, one's starting at 1, and they're going up and over at the same rate, or they'd be going actually down because they have a negative slope. So they're never ever going to touch, they're never going to meet. So there is no ordered pair solution. There is no solution, period. So we say that because there is no solution, the system is inconsistent. It's an inconsistent solution or system. So let's solve the following and determine if it's consistent or inconsistent. Now, you can solve this however you want. If you want to get this in slope-intercept form and graph it, be my guest. If you want to move the 2x over and make it so that they'll line up and then use elimination, again, be my guest. But I am going to use substitution because I already have y all by itself. Y is equal to this. So I'm going to come over here in this equation, find my y, and I'm going to replace it with what it's the same as. So my x plus 3 here stays the same, equals negative 14. All that stays the same. But because my y is the same as 2x, in place of the y, I'm going to put that 2x. Now we can solve. X plus, if I multiply this, I get 6x equals negative 14. X plus 6x is 7x. 7x equals negative 14. Divide both sides by 7, and x equals negative 2. If x equals negative 2, we plug it in place of this x. 2 times negative 2 is negative 4. So my ordered pair solution is negative 2, negative 4, and it is consistent and independent because I have exactly one solution. Again, if you was going to graph these, you would find the same thing. They intersect at negative 2, 4. All right, so looking at this one looks to me like it's set up to solve using elimination. Again, if you like graphing, be my guest. Manipulate it so that they're in slope-intercept form, graph them, go for it. Or if you want to get one of the variables by itself, again, go for it. But I see that if I add these together, immediately those are going to eliminate. So my work's mostly done. 3 take away 4, or 3 plus a negative 4, however you want to look at it, is negative 1y. 6 plus negative 10 is negative 4. Divide both sides by negative 1, and y equals a positive 4. Now, 2 times x plus, I'm just using this top equation. In place of that y, I'm going to put a 4. 3 times 4 is 12. Subtract 12 from both sides, and I get negative 6, because 6 take away 12 is negative 6. Divide by 2, and I get negative 3. So my ordered pair solution is negative 3, 4. Because there's one solution, it is consistent and independent. Okay, again, solve the following. To me, this looks like it's set up for elimination. I'm just going to change the sign of everything so that I can add them together. 2 and negative 2x is gone. 3 and negative 4y is negative 1y. And 6 and negative 10 is negative 4. This looks oddly familiar. Once I change these, this is the exact same problem that I had above. So we know the solution is going to be negative 3, 4. And it is consistent and independent. All right, so looking at this one, there's nothing that's going to eliminate right off the bat, but I know that if I multiply all of these terms by 2, I'm going to have negative 2b and a positive 2b, so those will eliminate. So I'm just going to times everything in this top equation by 2. So 6a minus 2b equals 4. Now, go ahead and line them up. Plus 2b equals 3. I'm going to add them together. 7a, boom, that's eliminated, equals 7. So clearly a equals 1. 7 times 1 is 7. Now we can find what b is. I'm just going to use the bottom solution. 1 plus 2b equals 3. Subtract 1. 2b equals 2. So clearly b also equals 1. So my ordered pair solution is 1, 1. We can check it. 3 times 1 is 3. Take away 1 is 2. 1 plus 2 times 1, which is 2. 1 plus 2 is 3. It works. So it is consistent and independent. All right, now this one says shade the area that shows solutions for both inequalities. So we have this y is greater than x minus 4. So if I imagine shading the values greater, then I'm going to be shading up above this line, up above the black dashed line, right? This one says I'm looking for y is less than or equal to negative 2x plus 2. So this time I'm shading below it. So if I shade above this one and below this one, I can see that this area over here gets shaded twice. And we can double check that by picking a point. Let's just do negative 1, 0. It should be true for both inequalities. Is 0 greater than negative 1 take away 4? Well, negative 1 take away 4 is negative 5. Is 0 greater than a negative 5? Sure is. Let's try it here. Is 0 less than or equal to 2 minus 2 times negative 5? Negative 2 times negative 5 is a positive 10. 10 plus 2 is 12. Is 0 less than or equal to 12? Yes, it is. So I know that I shaded the correct region because I shaded the part that included that point that works for both inequalities. Okay, so now we've got to graph and shade this one. The problem here is this isn't in slope-intercept form, but we know we can easily get it there by moving the 2x to the other side. So we're going to subtract it from both sides, and we still have that positive 8. So we'll go ahead and graph this. I start at positive 8. I go down 2 over 1, down 2 over 1, down 2 over 1. And here is my graph. It should be a dashed line because we have greater than, not greater than or equal to. Okay. So now we're shading above this line. So I'm shading up here. I'm shading the y values greater than negative 2x plus 8. Okay, let's look at this one. Thank goodness it's already in slope-intercept form, right? So we're starting at 7, and we're going down 2 over 1. So these lines are parallel. They're extremely close together. And this time I'm shading all the points below the line. Pretend that's straight. Because it's the y's less than this. So when I do the shading, remember what I'm looking for is the area that got shaded twice. Well, nothing here got shaded twice. I shaded above my dark purple line. I shaded below my blue line, so there's no overlap. So this system is inconsistent. There are no solutions. There's no overlap in the shading. All right, and that finishes up our review. I hope this made sense. Make sure to know that if there is one solution, independent people do things alone, by themselves, just one of them. One solution is independent. No solutions is inconsistent. It's not a consistent system. And that is our review, folks. Have a great day.